Good evening, students.
Good evening, ma'am.
Good evening, Ritika. Good evening, Shweta. As your exams are approaching, I just wanted to ask you that if you want to have a revision or anything of a specific part of a syllabus. I cannot hear from any one of you.
Ma'am, for me, the exam starts next month, so I don't have any topics on which I need revision.
Okay. The model exams are going on.
No, ma'am.
Okay. Which chapter is going on in your school?
Ma'am, in chemistry, they are about to finish thermodynamics.
Okay. Yeah, I think we had a conversation last time about it. So are you able to understand what they are saying or telling you?
Yes, ma'am.
Are you solving the questions regularly? Because thermo is basically about the numericals and their practice. In the last class, I have told you I would just like to remind you that we discussed what are the weak and strong acids and bases, because they become handy when we talk about either thermodynamics or equilibrium or any one of these chapters, right? So please remember, weak acids include only acetic acid, and weak bases are ammonium hydroxide and H2S, and rest of them are strong acids and strong bases. Weak acids and weak bases will dissociate maximum to the extent of the 3%, all right? And that governs a lot of part of the chemistry. Then we were discussing about the various types of various types of heats of reaction, right? And this is probably the last topic which we covered in the class, was that we talked about the heat of phase transitions. Phase transitions means when you convert a solid into gas or solid into liquid, liquid into solid, and so on. So as I told you in the last class also, you always have to benchmark it or take it as 1 mole. You must be having a common entity to, I'll say, compare these, right? And what is that entity? That entity is mole. So that is, we always be defining them as that enthalpy changes. I believe enthalpy and enthalpy is clear to all of you now. That enthalpy means we are talking about the total energy changes because of the P delta V work done, or as well as the internal energy. Total energy changes taking place when 1 mole of a substance is undergoing at the specified change. Moving on, let's talk about the Hess law of constant heat summation. I'll say this Hess law of constant heat summation is definitely not applicable to us in the day-to-day life. It simply means that suppose there are two ways of going to your school. From home to school, there are two ways, right? I believe one of them is going to be much more economical as compared to the other one, right? Is it true or not?
Yes, ma'am.
Okay. But when the chemicals are undergoing change, we do not say so. They say there are reactions which are independent of the path. For example, if we have, I want to convert A into B, I can do it by this method, that I am converting A into C first, Then I'm converting it C into D, and D is finally changed into the A. Oh, sorry, B, the required product. In this case, I'll say total heat of reaction will be equal to delta HR1 plus delta HR2 plus delta HR3. There can be a direct method also, right? So what can happen? That A can be convergent into B directly. That I call it as a path 2. There can be any other path also that you can convert A into B via, let's say, first you convert it into X, and then X is converted into B. And let's name it as path 3. They say the total energy changes taking place during the conversion of A to B are independent of the path. That means energy changes, total energy changes in path 1 will be equal to path 2, and that of path, and they will be equal to path 3. I hope it makes sense to all of you.
Yes, ma'am.
Okay. Now, talking about what are the applications. The thermochemical equations, as I told you, thermochemical equations are those equations where you specify the heat changes also. Normally, we do not write what are the heat changes taking place during the reaction, but in a thermochemical equation, we always mention the physical state of the substance, as well as we specify what are the heat changes taking place during this transformation. So these thermochemical equations can be added, subtracted, multiplied, or divided like a mathematical equation, right? Is it making sense? That you can multiply the entire, like when you, I believe all of you have mathematics. For solving a certain numerical, you sometimes you multiply the equations by, sometimes you subtract and then multiply. Then there are certain reaction for which the heat of formation is impossible to measure, especially the enthalpy of a reaction, right? Like the CO, some reactions may be explosive, right? You cannot do it directly. So what you do, you apply the Hess law, that is you prepare the substance via indirect methods, measure the heat of reaction of every step 1, 2, 3, as I have told you, and then you add them, right? There are certain processes which do not take place directly. Methane cannot be prepared from carbon and hydrogen directly. When we say it cannot be prepared directly, by saying so, we mean that the reaction is either very slow or very explosive, maybe very expensive also, or the experimental conditions are too difficult to manage. That means that, just take a simple example. When you take an ice cream from a vendor, it's perfectly chilled. But if you keep it in your refrigerator for some time, it melts. Even if you try to freeze the mixture of milk and make make ice cream out of it, the texture will not be as great as you get in the market, because the refrigerator does not give us that much temperature, right? And we cannot have that huge machines having such a low temperature to make the ice cream, because that is not economical, right? So sometimes there is an economical barrier. So for such a reactions, we say we will be using Hess law to do so, right? Then some reactions are very slow. One of the examples is that conversion of coal into diamond. You must know that the sources of coal and diamond are same. Chemically, both of them are carbon, right? So the mine from where we get coal, from the same mine, we get the diamond also. Conversion of coal into diamond is a very slow process. It takes not hundreds, but it takes thousands of years to take place, right? Then we say calculation very fast. As I told you, somebody wants to find out how much energy will be required to crack while we bust a cracker. A very fast reaction, very dangerous reaction. So we will be using indirect methods, right? This is again helps in the formation of, calculation of heat of ionization of weak acid and weak base. These reactions are, the energy changes are too slow or too small to be measured. Like if you have a water at 25 degrees centigrade and water at 30 degrees centigrade, both are room temperatures. Touching any of the container will not make you understand which one is hotter and which one is colder. So they are negligible changes, right? Somebody who always have a body temperature, I'll say, my hands are always cold. To me, the 30 degrees centigrade will appear to be great or good. But to somebody, 30 degree will be feeling very hot. So if the heat changes are too less, even then they can be measured or they can be actually calculated using the Hess law of, we call it as completely as Hess law of constant heat summation. Then calorific value of fuel. We are using various types of fuels these days, right? What is the purpose? The purpose is to find out the best fuel. One of the aspect is that its calorific value should be very high. Calorific value high means that by burning 1 gram of this particular substance, you must be getting a very high amount of heat, right? Then comes the other things like it should not produce polluting gases like carbon dioxide. It must have a low ignition temperature. That means it must catch fire easily. So it's not, and if you are wasting fuel for finding calorific value, that also does not make sense. So what you should do, you use the theoretical data or the indirect data to find its calorific value, right? To understand these things better, let us solve this question. I'll give you, I think this must be covered in your school by now. Is it true, Ritika and Shweta?
Yes, ma'am.
Yes, ma'am.
Okay, then quickly tell me the heat of reaction. To help, I am giving you certain hints. First of all, you have to know what you want to get. you have to get the equation. This time you are lucky that I have given you the equation that you are given to find out the heat of reaction of this reaction, right? Of the given reaction. That will be sounding better as per English is concerned, right? So what do you have? You have to have carbon dioxide and hydrogen on the left hand side of yours and CO and water on the right hand side of your equation. So for that, what you have to do? You have to reverse the equation 1 because you need to get carbon on that side. Then add equation 2, I'm so sorry. You have to reverse the equation 2. Then add equation 3. Now what else is to be done? Quickly find it out. Any answer from Ritika and Shweta? At least say yes or no. I was just telling you that you have to create an equation in which carbon dioxide and hydrogen. Fortunately, only one molecule. Had they been 2 or 3, you would have to multiply them by appropriate number, right? You have to multiply them and then you have to add or subtract that. As I have told you that heat of formation of carbon monoxide is difficult to calculate. This is an indirect method. For example, right? What you are doing? You are taking hydrogen, heat of formation of carbon monoxide and water. Then you are getting the heat of formation of CO2 also. Now what you have to do? You have to add all three equation. Carbon will get cancelled. Oxygen, you can see half and half oxygen, and that is oxygen is on the other side. Oxygen and oxygen will get cancelled, and this will be the required equation. And if I can ask, and if you can reply, Ritika and Shweta, where you were stuck, that will be helpful in the helpful for me to tell you how to solve this question, because this is one of the must ask question in the examination. Would you like to tell me something? And when you are adding or subtracting, then please be careful, right? Pay attention that when I have said reverse equation 2, I have reversed the sign of delta H also. These are the smaller nuances or the details of this particular calculation, right? Is it clear, Ritika, now?
Yes, ma'am.
Okay. We have done a part of it in the last class, but I'm again repeating it because there are certain enthalpies which are usually asked and which might not have been clear in the in the last class or in the still previous class. So it's better I force you to write, because I have to use the word force, right? It's not a volunteer act. You have to be forced to write that and remember that, so as to get a get good marks in the examination. As I have already told you, standard enthalpy means when you say that everything is done in the standard state. And the standard state, just to make you recall, standard state is the physical state of substance at the room temperature, right? So butane is a gas, oxygen is a gas. So what standard enthalpy of combustion? What does that mean? We did enthalpy of combustion. Now we have to do standard enthalpy of combustion, right? That is the enthalpy change when 1 mole of a substance is completely burnt in its standard state. Here we can add on few more things. In standard state, to produce carbon dioxide and water. Now, why we are specifying it? Because sometimes or every time we get a small amount of CO2 also. So therefore, it is important to specify to produce carbon dioxide and water. Carbon monoxide, if you recall, we did it in hydrocarbons chapter also. Carbon monoxide is produced by incomplete combustion. I will try to give you the assignment on it because numericals are many from these particular two topics which we are trying to cover up today. We cannot cover them in the class, so I'll give them the form of assignment, or if time is left, we will do it in the class itself, right? Please note it down, not only in your copies, but in your minds also, please. 13 by 2, if you don't like it, put it as 26 and double the numbers on the other side. 13 by 2 does not mean anything will be half. It is just a method to balance the equation. When we are writing, we can write anything. We can write the fractions, atoms and molecules in fractions also. But actually, they do not exist that way, right? Now, enthalpy of atomization. Please remember this reaction, this definition for class 12th also. In class 12th, we have a chapter DNF block. There, since last 3 years, continuously, they are asking a question on enthalpy of atomization of D block element. So the first task of a teacher is to teach you that. And the second task for the student is to understand this. Only then you can define and describe it, right? So the enthalpy change on breaking 1 mole of bond completely to obtain atoms in the gaseous state or the gaseous form is known as enthalpy of atomization, right? Again, 1 mole is the key word, and the atoms in gaseous state, because why it is important to put it as solid or not as solid or a liquid? In solid state, atoms are closer to each other, or I will say in solid state, they are closest to each other. It will be difficult to separate them, right? And energy will be required to separate them also. So therefore, we say, let's not take as a solid, let's compare them as gases, right? I'm giving you a minute to please copy it down. It is not written in NCERT. Please copy it down. You must be wondering that why at many times I become, or I say or pursue you to write it down, because these are, and because although I know that you'll be getting the link or you'll be getting the download of this lecture itself, but in the examination, you have to write it. And that's the only way to make you write, right? Or rather to ensure that you are writing. So please write it down quickly. Okay. Then enthalpy of ionization. Can I ask you what is the definition of ionization potential or ionization? We covered it in the chapter of chemical, rather periodic classification. Quickly. We'll be having exam soon, right? What is ionization? Shweta, any idea how do we define ionization? Half of the definition is on the screen itself. When we were studying periodic table, we did one thing that we said, we did two properties. One was ionization enthalpy. And the other one was electron affinity. During ionization, we say an atom gives out an electron and becomes a cation. In electron affinity, we said an atom accepts an electron and becomes an ion. So ionization enthalpy will be the amount of energy released when an electron is removed from an isolated gaseous atom. Again, isolated means that it must not be attracted by the other atoms, because then you have to do additional work and you have to supply additional energy, right? So this is the enthalpy change that accompanies the removal of an electron from an from each atom or ion in one mole. In 1 mole of gaseous atoms or ions. If you remember, we talked about the first and second ionization enthalpies also. For example, calcium, its atomic number is 20. If I write the configuration according to Bohr's law, it will be 2, 8, 8, 2. So it has to lose 2 electrons, give out 2 electrons to become stable. So what it does, it gives 1 electron and the energy supplied to it to take away that electron is plus 590. Now, you are taking another electron. Now, do you see the jump? It is more than double almost. Or we can say it is doubled. The question is why? Shweta and Ritika, please answer. This is question from periodic classification chapter. Why successive ionization enthalpies are increasing always? Dear students, in your benefit, please revise them. Let me explain it to you once again. Calcium was having 20 protons and it was having 20 electrons. It gives away 1 electron. Number of protons remains 20, but electron become 19 and it becomes calcium plus 1. It has to lose 1 more electron. It becomes Ca2 plus, right? It becomes 20 and 18. There are 2 questions in it now. First of all, When second ionization enthalpy is high, why it is going to do so? When energy required is more, then even then why it does so? That is the question number one, right? Number two, why it is having more? Logically, it seems if one electron 590, another electron, any more, only 590 plus is required. But it is saying it is requiring double. Reason being, the positively charged cation, monovalent cation 2019, it will have more attractive power. The nucleus has 20 protons and they have to attract only 19 electrons now, as compared to the 20 protons and 20 electrons. Now, since force of attraction has increased, logically you will have to spend more energy. More importantly, even as a layman or a new student to chemistry, we can say that it has already acquired a positive charge. If it will want somebody to give the electron rather than what I'm doing, I'm taking away the electron from it, right? So therefore, more energy is required and it is done so. We prefer to spend money. We prefer to spend energy on it because that makes it stable, right? So it is just a I need to make you recall. So you can take it as a revision for your periodic classification chapter. Chapter is comparatively smaller, having lesser number of concepts, but it needs a revision from my side, from my suggestion to you, right? Then, what is a bond enthalpy that we need to understand? Bond enthalpy will be a we have already done the chemical reaction mechanism for organic chemistry, right? Organic and inorganic, nothing great about difference wise, there is no great difference. It's just that they differ. One has a homolytic, another has a heterolytic fission. I believe you understand these two terms. We have recently finished them, right? So what happens during a chemical reaction? A bond is broken up and then a new bond is being created, right? We always know that breaking will require an effort, that is, energy will be supplied. And when a bond is formed, like we get to know many people, we make friends, we become happy. Similarly, how do atoms express their happiness? By giving out this energy and becoming stable. So you will supply energy first of all to break the bond, and then new bonds will be formed and the energy will be released. So there seems to be a big formula on the screen. Can somebody tell me what is this symbol? A sort of M in a different direction. Say, I'm not a maths student, I don't know. I think it is a sign of summation. Am I right?
Yes, ma'am.
Okay. Where we say that it will be total number of bonds and the energies required to them. If they have 4 bonds and 4 bonds have XYZ energies, then sum of XYZ, right? So bond and enthalpy of reactant minus product. Till now, I'll just try to make you memorize things also. Whatever formula you have seen everywhere, including that equilibrium, we use product minus reactant. Delta Ng is always equal to delta Ng product minus reactant. But remember, bond enthalpy is probably the only formula as far as your class 11 syllabus or even class 12 syllabus is concerned, which requires sum of energies of reactant minus product, right? Otherwise, it's always reverse of it, product minus reactant, right? Now, the bond dissociation enthalpies or bond enthalpies are of two types. One is called as bond dissociation enthalpy. In this case, what happens? We say that the bonds are of similar type. In Cl2, what do you see? That there is a bond between two chlorine atom. So change in enthalpy. Again, as I told you in the last class, we need to be smarter. We cannot say every time whether, or we cannot predict that whether energy is absorbed or given out. So total energy changes accompanied with so and so reaction is the best or a better phrase to deal in such situations. So what do we say? Change in enthalpy. When one mole of a covalent bond of a gaseous covalent compound is broken to form products in the gaseous phase, right? Everything has to be in the gaseous state. I'm repeating myself so that it helps you in memorizing that whenever you are talking about the thermo, every reaction has to be in the gaseous state, because in gaseous state, the reactant and products are far away from each other, and you don't have to supply energy to separate the uh, reactants or the products molecules, right? So in a simpler language, you may be fine. I have tried to write it differently, but in a simpler language, we can say total amount of heat changes accompany when 1 mole of a gaseous covalent compound is broken down to produce a gaseous products, right? Note it down quickly. Okay. Now, we will be talking about the mean bond enthalpy. Before we do it, I'll tell you why I have to teach you this, because I've seen this here. Many teachers on the many schools have preferred to do it in the name of what we call it as application based question. So it is important for us to understand this concept first. We are saying there is a CH4, a pretty familiar compound for all of us, right? If I say one bond is broken of, if I break a one bond of CH, if it requires X joules of energy, expected answer from all of us, as including me, should be that total energy content of the methane will be what? 4CH bond should be X into 4X joules of energy should be required, but that does not happen. We must understand, once we break the 1CH bond, the proton-electron ratio changes, right? And as a result, what happens? Attractive and repulsive forces also changes. To explain to you it in a much simpler manner, only one thing comes to my mind. That was when, as a student, we were supposed to tie Rakhi during Rakhi Day, or we can take it to even our two brothers and sisters, right? And if assumingly that every brother gives the same gift to the sister, we should be getting, if I have 6 brothers, I'll be getting 6 ones. But it does not happen. Every brother or a sister, according to their choices, they give the different types of rakhis to them, and they get a different type of gifts also. Similarly, it is not correct to say that all the 4 bonds of CH are of similar nature. They appear to be similar, they may be similar, and they are similar. But once you break even one of them, the rhythm, the attractive repulsive forces between the other 3 CH bonds also break down. As a result, we have to find the average value of the dissociation of CH bond. I hope it makes sense to all of you. Give me a second. There seems to be a certain fluctuation in the light. Now, as you can see on the screen, all the 4 bond dissociation energies are different. For first bond, I require only 427 kilojoules. For dissociation of the second bond, I require 439. Third is 452 and fourth is suddenly 347, right? And to find it, when we find its average, it comes out to be as 1665 kilojoules for breaking 4 CH bonds, right? So for polyatomic molecules, we must not say that all the values are equal. You will be given a separate 4 values. If you talk about C2H6, then how many values would I expect? Or how many values should you expect? If you have C2H6, any answer? See, this is C2H6. I will say I require to find its energy. I require an energy data for CC bond. I require energy data for CH bonds, and that too 6 CH bonds, right? Unless or until they give me the mean value. I will ask them to give me the 6 different datas. Practically, when you are doing a numerical, you will be given the average values, but read your question carefully, especially if you are preparing for your JEE exam. Yeah, okay. I think class 11th is not supposed to give the JEE exam, which is, I believe, on in a day or two. Are you eligible to appear for JEE exams? I think no, only the class 12th students are eligible. Okay, no issues. Next year we will be there. So, the total bond energy value, which we have calculated for 4 CH bond, as you can see on my screen, it is 1665 kilojoules per mole, right? For one, what we have to do? We have to divide it by 4, like this, to get the value of, or rather mean value of bond enthalpy. Is it clear? When I again say, when you are doing a question, you need to understand what they have given, whether they have given you the bond enthalpy value or mean bond enthalpy value. For your case, I believe they must be giving you the mean bond enthalpy value. Has this concept been taught to you in your schools or not, Ritika and Shweta? Please reply. I assume you will be given 416 kilojoules only. Now moving on to some more bond enthalpies. Enthalpy of solution, enthalpy of dilution. Main thing is that we must understand the value of these words which are written here. Because if you miss this word, there will be a problem. You will be thinking that you have written the correct answer, but actually you would not have written the correct answer, right? Infinitely dilute solution. That means the solvent has to be taken in excess. That is very important. Enthalpy of solution means the total enthalpy changes occurring or taking place when 1 mole of a solute is completely dissolved. Solute dissolves and completely dissolves are one and the same thing. Is completely dissolved in the solvent to form an infinitely dilute solution, right? So when you dissolve sodium chloride in water, the enthalpy is +5 kilojoules per mole. That is, heat is absorbed, right? Now, this heat of solution can be exothermic or endothermic. As I told you, enthalpy of combustion is always positive, because to burn something, you always need to supply the heat. Like whenever you are burning your gas stove or any other form of a stove, what happens? For a fraction of a second, with the help of the lighter or the matchstick, or maybe a burning candle, you have to supply that much heat, sudden heat, a large amount of heat, and it catches fire. So once the reaction starts, it becomes self-sufficient. At every step, large amount of energy will be evolved, and it will be going on till the entire gas cylinder is consumed, right? So that we say heat of solution can be exothermic or endothermic. If you get a chance to see when a whitewash is going on at your home, whitewash does not mean the distemper rather, not distance, distemper, not the colors which we put on with the various brands. There must be a lime water. Calcium oxide and calcium hydroxide solution is being pasted on the walls, right? All the white colored. If you see somebody is dissolving that calcium rocks in the water, you will see it will start bubbling. Unfortunately, if you have seen the plaster to fix the broken bones, these times I believe they do not do so, but as a young child, once I got fractured, they will put a bandage in plaster of Paris or the solution, and believe me, it is boiling the moment it comes out. So you will notice that it is boiling. So I was telling about the whitewash. Do notice when there is a whitewash going on, especially the white colored roofs whenever they are painted. The moment they dissolve that white colored powder in water, it start boiling. It's exothermic reaction. Many a times it is a endothermic reaction. In day-to-day life, you cannot feel the exo or the endothermic reaction. Reason being the heat exchange is too low. Like when you are stirring your milk, even at room temperature, you will not be able to, you are supplying what? Mechanical work is done on it. Heat must be changing. How much? You don't know. You don't know does not mean you will not be able to it is not taking place. It's simply that it is too less that you cannot feel it. Then this is very important, and very important from the perspective of the reasoning question. Enthalpy of solution is the sum of two imaginary steps. They do take place, but since we cannot separate them, we cannot draw the boundary. Like when we sleep, it is night. When we get up, we can see the sunlight. Most of the time, we do not see the sunrise. Every day, for a change on a vacation, we can always go and find it out. But every day, we do not. But it does not mean sun does not rise. Sun rises everywhere, right? Let's not go into details. Then somebody will say, okay, sun does not rise, sun does not set. So let's not go into those details. Reverse of the lightness energy and the hydration enthalpy. I'll tell you a very basic thing about it. First of all, the solution dissolves in water. And usually, if I talk about simply sodium chloride, what happens in it? The sodium chloride changes into the sodium chloride kept in the bottle in your kitchen will first of all change into Na plus and Cl minus n. And where it is happening? It is happening inside a container filled with water, right? Now, what is water? Water is having two lone pair of electrons, right? What is water? I was just laughing at my own statement. Water means it is electron rich or electron deficient. It is electron rich. What it will do? It will form coordinate bond, or it will form a type of a bond with water. And this is an exothermic process. This is called as hydration. Hydration means water forms a special type of a bond. I wish you can recall what is a coordinate bond. It's a one-sided covalent bond in which both the electrons are being supplied by the one party, that is water in this case. Sodium being electron deficient, water will provide it or form a coordinate bond with it. And this will be an exothermic process. Now, what is lattice energy? All of you must have seen the cube. You must have played Ludo. Right? Ludo has 6 faces. Imagine there is one sodium ion here, another sodium here. What do you say? You can see face of one dice, right? On the face of one dice, there are 4 sodium ions, and there is one chloride at the center of it. It will happen at all the places, assumingly. This is called as lattice. In fact, it is a unit cell. You have to imagine that it is manifested in all direction. You have just close your eyes, imagine that you are given, let's say, hundreds of these Ludo dices with you. And what you are doing? You are trying to put them first in the horizontal row, then above, and above. You make a, I will say, a wall of it, right? Then you increase the thickness of wall. As a result, you will get a 3-dimensional structure that is called as lattice. Now, when we have to dissolve or when we dissolve sodium chloride, what happens? That the sodium ion and the chloride ion, they have to leave their position in their respective lattices. These ions come into solution. And the energy required to pull them from their positions in the lattice to the solution or the water is called as lattice energy. And it is positive. It is to be supplied, right? So whenever something dissolves in any other thing, that 2 processes take place. One in which energy is being supplied, and other in which energy is being liberated. And it is because of these two, some of the things dissolve in water and some of things do not dissolve in water, right? Whenever the total sum of these two is ultimately negative, you have to supply, let's say, 50 joules of energy and you are obtaining, let's say, 70 joules of energy. Process is exothermic. Then the something will dissolve into water quickly. The substances like spices, the turmeric, the what we call it as, I'm not getting the name of that garam masala. What do you call it as? Let's think of turmeric powder only. Cumin seed powder also. They don't dissolve in water. Try dissolving them. Don't waste. Take only 1/4 or a very little of it and then dissolve it. It does not. Because for them, the value of lattice energy is too high. It is very difficult to put them or to pull them out of their lattice structures and make them into solution, right? It is important for, you may be thinking that why I'm taking so much of a time to explain it to you. We'll be talking about the Born-Haber cycle next. And there it is required, right? And it is important that why something is soluble in water and why something is not soluble in water. Yeah, here it is. When we dissolve sodium chloride in water, what we say, what is a process? Sodium chloride is solid. It has to undergo so many things. First of all, as I told you, let's go to them slowly. First of all, what you have to do, this is enthalpy diagram, or this can be taken as a Born-Haber cycle. Let's do something other than chemistry. have you taken out money from any ATM? Have you ever used your ATM cards? Ritika and Shweta, choose one option. Either tell me whether you have used ATM cards or not to withdraw money, or do you know what are the steps in making tea? Beginning with you, Shweta. List the steps in any of these two processes.
ATM card.
Okay, tell me what are the steps.
You have to insert the card, choose the language, choose
Insert. Okay,
save,
okay. So let me write. Insert the card. Then choose language.
select the
Correct.
language.
Okay.
Uh, then you have options like deposit and stuff. If you have to withdraw money, if you go to savings account.
Okay. Choose the option of the savings account. Okay.
Enter the money and then PIN code, I guess.
Enter the amount.
And then the ATM pin. I'm not sure if the ATM pin comes first and then the amount, but
Okay.
these two first.
Wait. Collect money. Right. Take out your card. Right. Then keep money safely. That is also required or not, Shweta? Yeah, Ritika, can you tell me how do we make tea?
Ma'am, we put the milk into a vessel, turn the stove on, and wait till the milk gets boiled.
The second
Add
step,
tea powder,
milk and
sugar.
vessel. After that, what you said, Ritika? Please be a bit slow. I have to match your speed. Turn the burner, I believe you said.
Turn this. Yes, ma'am.
Yeah, then,
Wait till it gets boiled,
okay.
and then add tea powder, sugar, cardamom.
Yeah,
And then we filter it, I guess.
then what do you do?
We filter it.
Heat,
Filter.
filter.
Yes, ma'am.
Okay, filter, then drink.
Filter it to a cup.
Ah, agreed. Okay. If you ask me, insert the card. First of all, we need to have a card. We need to have money in the account, right? The two I have chosen these two processes. They seem to be very simple, but yet they are very complicated. First of all, we need, as I told you, that we need to have an account. We need to, maybe your father's or your mother's or yours account. We need to have an account with the money. We should have a correct card. We must know its PIN. That I remember Shweta said to me. And then more or less the things are fine, right? Then talking about making tea. First of all, there has to be desire to have tea. The second thing, you need to have a vessel. You need to have a burner. That is, we need to have a basic requirements in place, right? Utensil wise. There can be many more steps. Even we are not here to dissect what you said. We are just here to tell you that there is something called as Born-Haber cycle, where we understand that you have to, like, if your mother has to cook the dinner for you, then right from the scratch, there are many things which are very silent but very important to us. Everybody needs to be hungry. There needs to be enough money to buy the vegetable. Then If you have purchased, then they must be kept at the designated place with the proper storage, right? Then she must know who wants to eat what. Then she has to come to a proper conclusion out of so many options which it will be best to cook. What is the timelines? The simple processes look very difficult, like for your life. If I ask you to do an assignment, okay, then it will be a burden for you. I understand that. Why? Many things going in your mind. Next month you have your exams. Before that, your maths teacher must have given you something, physics teacher. Mom must be very worried ki you are not helping her in the kitchen. Maybe many other things must be going around. Similarly, when we are making a Born-Haber cycle, it is very important for us to write the every step very clearly and neatly. They just ask you to make that diagram. In some other class, I just asked, what do you do to go to school? The answer was we take the time, we look at the timetable, keep the books and copies, dress up and go. Nobody in the classroom mentioned that you have to wear the proper pair of socks and shoes also. You have to tie your hairs also, isn't it? Similarly, when you are doing Born-Haber cycle, we need to know max. That was the reason I told you. Dissolving something, you have to imagine it clearly. What you have to do, if I ask you to dissolve sugar in water, so it is that you will have a container where you will be pouring out that sugar. You need to ask me how much sugar. I'll tell you 2 teaspoons. Which teaspoon? If you have seen the measuring spoons are there. So that's enough of it. We need to be very specific in the step and the amount. That's the crux of what I'm trying to tell you, right? Similarly, if you are dissolving sodium chloride, it's not that easy. As I have already told you, first of all, you have to take them out from the respective position in lattice. You have to supply, as you can see, you have supplied this much of energy, right? Then what it will do after you supply lattice energy, sodium will convert into Na plus and Cl minus. Remember me, they will still be in the lattices only. Then what you have to do? You have to add water to it. They have to be converted into Na plus aqueous and Cl minus aqueous. How? Which I have explained to you in the earlier process. They have to be hydrated. Na plus has to be surrounded by many water molecules. So has to be the chloride ion also. Of course, that will be surrounded by lesser, but that has to be surrounded. And then only you can find out what will be the enthalpy, right? Enthalpy of solution, you have to dissolve sodium chloride in water. What you have to do? You have to supply the enthalpy and lattice energy, make it as Na plus and Cl minus. Then you have to make them an Na plus and Cl minus by supplying. When you are doing so, energy will be given out, right? And then the difference is what? 5 joules. That will be absorbed, right? This is enthalpy diagram, or it can be considered as an example of a Born-Haber cycle, right? Where, of course, yes, you won't be given the values, but you will have to draw, as I have asked you an activity. Tell me the logical steps for drawing this making tea. Now, there's one question. Out of context, I'm asking, just to give you an activity or an exercise to think about it. I am also searching an answer to this. I'm asked to explain to a blind person the rainbow. How would I do it? Or how can you do it? Somebody who is blind, how can we explain that there is a spectrum which is red, green, blue? I really do not know. Any idea, Ritika? Shweta, any idea? Just think about it. Because we are very good at imagination. We can imagine that God will be there. What is life after life? So someday this just question, I was watching probably some TV program or something. Then I just realized how difficult it would be for me to explain. I really do not have any answer. Let's move on. So that's all about the enthalpy diagram. Then we will do the enthalpy of dilution. Again, you have to make such a dilute. Again, the keywords are highlighted here. Enthalpy change, of course, when a solution of one concentration is diluted further to form solution of another concentration. Uh, like sometimes there is a lot of salt. By mistake, I have put double salt in while cooking the vegetable. What best I can do? I will put a small, what I call it as a roti or some dough into it that will absorb the salt from it, right? So you are converting one concentration to another, right? Milk is too sweet, add more water, add more milk to it rather, not water, right? So you have to add enough water that the change is visible. Suppose it is too sweet and you have added hardly, let's say, 3 or 4 teaspoons, not that what we call it as a ladle, the bigger one. So half cup of a milk, if you are adding, that means only then that the sweetness will become less. By adding 2 or 3 teaspoons, nothing will happen to sweetness. Solution must have been diluted, but the diluted solutions cannot be felt that way, right? So it is diluted to another concentration is the key word in this, right? I'm highlighting it with red. And please note it down. Write it down quickly. This I have already told you. Rather explained the process. The definition is here. The enthalpy change that takes place when 1 mole of a solid ionic lattice forms from its gaseous atoms. Again, important thing is that the ions, gaseous ions, I'm so sorry, they have to be in the gaseous state, right? Because as I have told you many a times, you must be bored by it. But that's critical. If you don't put it as state, a teacher is going to cross it and give you the 0 instead of 1. It's only a 1-mark question, right? So that enthalpy changes which take place when 1 mole of a solid ionic lattice is formed from its constituent gaseous atoms, or rather, sorry, ions. Lattice energy is always exothermic, right? So quickly write down at least the definition. Now here it is Born-Haber cycle, and I think we have almost practically understood the crux or the important points of it. So that's what we are saying. It is impossible to determine the lattice enthalpies by experiment. It's highly impossible that you measure the energy changes taking place in one molecule of sodium chloride. You can always do it for a bulk, right? And bulk will always be solid for sodium chloride, whereas at every step you require it in the gaseous state. So what you have to do, you have to make a Born-Haber cycle. For every step, you will find the theoretical data, add them to find out what is the lattice enthalpy of sodium chloride, right? So because it is impossible to determine the lattice enthalpies by experiment, we use the indirect method, which is known as Born-Haber cycle. Again, I tell you, they will ask you to draw it for magnesium chloride. I'm telling you for sodium chloride, magnesium chloride, I'll give you, either I'll tell you the solution or I'll give it to you in the homework, right? The sum of total energy changes in a cycle is always zero, that we have already understood. This is the entire step. So what you have to do, you can start either from that end or from the bottommost step. You can read it logically, all of them, that what happens at what step, right? So first step, from where you want to study, where you want to start. If I say that if I have Na plus, or rather I have to start it from sodium. If I take this is my sodium chloride solid, right? So what you have to do, first of all, we said that you have to change it into gaseous state, right? So first of all, we will convert them into sodium gaseous state will not be possible directly. They do not sublimate. They are solids. The solid will change into liquid. Therefore, the first step is heat of fusion. Now you might understand the importance of teaching you or spending more than 1.5 hours on teaching all those definitions. The first one is heat of fusion at the bottom. Right? This is heat of fusion. So by absorbing the heat of fusion, it will convert into sodium solid and chlorine gas, right? Because chlorine exists as a gas at room temperature. Then what will happen? You have to get both of them in the gaseous state. Now I have written it as half Cl2. Please do not question it because we are referring to chlorine atom, right? So NaCl will give us only one atom. So chlorine atom cannot be written like this. So we'll be writing it as chlorine, half chlorine molecule, right? If you are hearing any noise from are you able to hear me? Because I can see a lot of, or rather I can hear a lot of noise at my place now. Am I audible to both of you?
Yes, ma'am.
I didn't get you. Is my voice clear or you can see a lot of background noise?
No, ma'am, I can hear you clearly.
Okay, fine. So it means I am hearing that noise because of that Ram Mandir puja, and a lot of processions are going around my home. Okay, moving on. First of all, we will supply it heat of fusion. It will convert into sodium chloride solid and half molecule of chlorine. Then we said by definition, everything has to be in the gaseous state. So we will again heat them. We will again supply them some energy. So as a result, sodium solid changes into sodium gases in the step 2 here, right? Then what we need to have? We need to have sodium plus. So what we will do? We will supply heat of ionization. As a result, sodium will convert into sodium plus, right? chlorine gas, and at the same time, when you are dissociating it, what will happen? The chlorine gas will be formed, right? So we will start writing it as chlorine gas, right? Then both of them will be converted into ions. Electron affinity, you will be supplying energy equivalent to electron affinity. Then you will be getting sodium gas and chlorine gas. Rather, sodium plus gas and chloride ion as a gas, right? And then you will have the lattice energy. So finally, that is how the cycle will be completed. By combining both of them, you will get this, right? In fact, they have told us in two different ways. Either follow the first one or follow the second one. If you have to convert the first, or this half is approximately for converting sodium chloride to Na plus and Cl minus, right? Now, as I was telling you, if someone wants me to do it for MgCl2, what I will do, I will not write Cl2 here. Half Cl2 will be deleted from this point. Then we'll be writing only Cl2, Cl2, Cl2. And here we will have an additional step, right? To convert Cl2 into Cl. Is it making sense? Clear to both of you? Assume that it is clear to all of you. Then we have a concept of spontaneity and entropy. There are certain reactions in the nature which are always spontaneous. Like if you allow the water to flow, what happens? It will always be flowing like this from higher level to the lower level, right? Similarly, if we have two gases, I have kept them in two separate containers, which are and both of them are placed in such a way that they are closed and they are not mixing. But what happens? The moment you open this plug, the blue comes to red side and red comes to the blue side, right? This is a spontaneous process. Like you put up a perfume, or you just lit an agarbatti in the or incense stick in a one corner of your house. It's a smell. It spreads all over the room or all almost entire room. Why? Because with air they travel from one place to other. That is their spontaneous reaction. Yeah, spontaneous action. Right? So what are the characteristics of spontaneous reactions? First of all, they are unidirectional. They are unidirectional. That means water will always fall from top to bottom. It will never go from top to bottom, bottom to top, whatever you do. Right? You have to apply the force. At its own, it will never do so. They are irreversible. If you have thrown water, you cannot stop it. Right? Then it is not concerned with the rate at which the process occurs. It may occur slowly, it may occur quickly, but it will occur only in a specific direction, right? All the natural processes are spontaneous, that is important, right? It proceeds with the equilibrium till the equilibrium is achieved. If you try to allow water to flow from top to bottom, some of water will still be locked up at your terrace. But till the time the equilibrium is established, most of them will flow down, right? Now, what is entropy? Entropy means randomness. We say solid is the most orderly phase, and the gases are most random. And solid are said to be most, I'll say, specified, or I will put it as least random or orderly phase. With every chemical reaction, the randomness or the entropy of the system is increasing. That whenever you are carrying, even if I am talking to you, what is happening? The molecules or the particles of air around me are being disturbed. That is, they were fixed at a particular position. Now the randomness is increasing. Whatever you do, you are always increasing the randomness, right? So randomness is measured by a property known as entropy. The thermodynamic property which measures the disorderness or the randomness is called as entropy, right? Okay. So with this, I would like to end the class. Because there are many formulas to discuss. Now you will have to help me by telling me, definitely in the next class, we'll be completing the chapter Hartley second and the third law of thermodynamics, and some questions on this are left. After that, should I pick up the redox or should I pick up the equilibrium for you?
Ma'am, can we go with the equilibrium?
Can we do the
Equilibrium.
equilibrium? Okay. So we'll be starting with equilibrium, and I'll appreciate if you can do some questions based on it, so that our efforts are fruitful and you score good marks in the class, right? So till what point, you were saying that you are almost at the end of this chapter. So till what point they have taught you in the class?
Ma'am, can you repeat what you just said?
I just said, okay, till what time? What point? What is the topic of this chapter going on in your school?
Ma'am, the same topic.
Okay, so good. So maybe a revision for you. So please do the questions as your school teacher and I suggest. So if you have any questions, then fine, else we will be ending the class soon.
No questions, ma'am.
Okay, thank you. Then see you on Wednesday, right?
Thank
Have a
you,
good day.
ma'am.
Okay. Have a good day.
Thank you, mom.
Welcome.